Hello, this is Devin Rose from Talking in Code, and I want to look at the bowling game Kata. This is something Uncle Bob Martin had done. He did it in Java to make a bowling game that can score a bowling game correctly using test-driven development, TDD. There's a few people who've done a C# bowling game, but I'd like to do it for the learning aspect too. So the first test we want is to test a gutter game. That's after we've made a bowling game project and a unit test project. I have Visual Studio 2013 Ultimate with Resharper in. Let's make a new project. There we go. And let's see, let's start with the class library. So make a bowling game class library. That'll be our main bowling game project. Then we'll make a unit test project called Bowling Game Tests to actually test this project. So we're going to add a new project. We could use NUnit also, but we're going to use the built-in MS Test. Let's call it Bowling Game Tests. Let's rename the sample class it gives us to Bowling Game Tests. Do we want to rename the class? Yes, we do. I'm going to test a gutter game. We're going to make a new bowling game, which doesn't exist. Let's just say we want to make a class for it. Well, it puts it here. You want to move it into, so it's using Resharper, into the bowling game project. And there it is. So delete the basic class already there. Let's go into that bowling game. We need to make it public so it can be seen by other assemblies. And this guy here. So we're now referencing the bowling game project. So we, alright, what if we call it game? And then we call it game here. Okay, well, it's happier with game, that's fine. Sometimes if you name things the same as the namespace, it gets weird. Alright, so we're going to run this test. I'm going to use Resharper. You can also do it with Test Explorer, or even, I think, right-click and say run. Yes, and it passed because it's just doing a game right now. We haven't actually tested a gutter game, though. Okay, so makes a new game. Now we've got that. So, but we actually want to roll, right? We want to roll 20 times. There's 2 rolls per frame, except for the last frame when there could be 3 rolls. We want to roll and hit 0 pins. So let's try that. So I is 0, upper bound 20, enter. We want to do game.roll. We hit 0 pins each time. Do control dot, generate a method stub for it. Let's go look over there. There it is. And of course, when we run this, we get red because it's not implemented. Okay, let's go back and look to see. It says, well, what if we just do nothing? Well, yeah, that will pass, but it's still just doing nothing. So now let's put an assert. So they do assert equals that the score is 0 and it scores a new thing. So we'll use the assert r equal. The expected value is 0. The game.score is what we're looking for. It doesn't exist, so that's not going to compile. Let's generate a property for that. And it's not an object, it's going to be it could be a uint, or it could be even less than a uint, but we'll just say it's an int. So we'll do a build succeeded. And we'll go ahead and run. We should, well, because it defaults to 0 is why that actually worked. Okay, so in order to make it fail, which is fine, they said, hey, what if we set this originally to -1? Set this. So we'll just say, hey, we're going to initialize you to -1. Of course, we're not doing anything to it yet. So what if we return 0? Then it's going to, or if we initialize to 0, run the test. Now it works. Okay, so now we're going to test all ones. What if you just roll one pin each time? We should get a score of 20, supposedly. Really, it's probably going to be different, but let's go back to our test. We're just going to do a naive copy-paste. I'm going to say test rolling. Let me say test hitting one pin per roll. It's a little more specific. And we'll do that. And we say, hey, it should be 20. Let's do that. Test gutter, game works. Test hitting one pin per roll. Does not work. Alright, so what if we come back over to game and say, hey, every time you roll, let's do score plus equal the number of pins you hit. Really, this is pins hit, right? Now I want to run both my tests and see what happens. Okay, they actually both succeed. So that's a naive implementation. But when we look at it, so we had a red failing test, green, now it's passing, but we want to refactor. So for one thing, we already have this repeated code here with game being initialized. There's a few ways to do that. We could actually make a member variable that's a game and have that reinitialize each test. Or what I often like to do is just real simple. Right now game doesn't have much, but it could have more in the future. So what if instead we say, just make a new function called setupGame, and in that game we say, let's return a new game. I like to keep the public and private methods separated, and even in a test file, you can even use a region if we want. Some people don't like these. I like them in moderation. And duplicate that here. So now we've got that. We're also duplicating the number of or loop that is saying, hey, roll a certain number with a value. I'm not sure what exactly I want to do there, but what if we say roll pins? So we want to roll 20 pins and 0 each time. Let's make a new function. Can call this number of rolls, and call this pins hit per roll. So in that case, that's there. That's number of rolls. And we forgot we needed the game too. So now this gets simplified too down here. We can say, hey, roll but do. And we like this because this is a A test that's set up, operate, verify. 3 steps. It's even in this case about 3 lines of code. Let's move this down into our private method area. Control-Shift-L kills a line in Visual Studio. Alright, we just did a little refactor. Are we still passing? We are. Okay, so we're feeling pretty good. Did Uncle Bob do a... Okay, so he did the second test, added the number of pins, and has he done a refactor yet? Let's see. Okay, so he did a minor refactor there. Now he has a roll many. Yeah, okay. He's using game as a member variable. That's fine. Can do that too. Just depends on your usage. Doing roll many. So this is the same refactor we kind of came upon. Okay. So now we've got a loop that rolls. Now a third test is test one spare. So the first roll we do 5. The next roll we do 5. Well, that's a spare, which is going to then affect this next roll. This third roll will affect our score. How many we get in that third roll? So we want to test one spare. Let's do that. Do a little copy paste again. Say test one spare. I'm going to set up our game. And in this case, we can just do game roll. They hit 5, hit 5. That's the spare. Then they did 3. And we know that from bowling that actually that should be a 17. No. The final score for that should be 16, but we need to also do a roll pins too. And how many do we have left after that? We've got 17 left that we don't hit anything on. Okay. So we expect this to fail. We expected 16, but got 13 because we're not taking into account the spare. Okay. So the problem is this is just naive. We don't actually have any memory of what we've rolled, and nor the concept of a frame. The score is just storing the score. The roll is changing the score, which is more like a side effect. So we don't have correct responsibilities here either. So we want to change it where rolling is just storing the fact that we rolled and hit a certain number of pins. Let's do let's make a variable. It's really an array, but let's make a list of ints. And we can call it rolls. Do a new list. In this case, we actually know that there's 21 as a capacity. And that's the 20 rolls, 2 for each frame, plus that last third roll in the 10th frame if you get to it. And let's say we also have the current roll that you're on. Make that camel case. Okay, so now whenever we roll, let's leave the score for now for like that and say we're going to do rolls, current roll, we'll increment the count there. So index into our list, and it's equal to the number of pins we've hit, so we're storing that value. We don't want score now actually wants to calculate the score. So let's remove that. It gets set to 0 anyways by default. Let's actually do something in this getter and do a calculation. So We can say is equal to 0, I is equal to rolls. What index do we want to go to? We actually want to go to whatever the current roll's been. So it'll start off at 0. Let's do current roll plus 1. So 0. I don't know if I like that. Let's try it like that. See what happens. And we want to say the score is going to equal now we're adding it up. Still isn't quite correct because we're not doing the spare case yet, nor the idea of frames, but it's at least a little bit better. Okay, so we need to take into account if this is a spare. We start at 0 and then 1, so if we start just adding and say the rolls sub I plus the rolls sub I plus 1 equal 10, then we want to add something here. I want to add the old value somehow, let's see. Yeah, but then that's just counting up constantly. We have to jump by 2's, do plus equal 2. This isn't quite right either. So let's have the idea of a concept of a frame. That's what we kind of need. So what do we have? The frame starts off at 0. Frame is less than 10. We're getting somewhere a little bit better. The score then so we're going up on, this needs to be frame. And we want to index I. So I is going to go, we have 10 frames in each of those 2 rolls. So the way that we'll calculate this will be on a per frame basis. We're still not there yet, but we're getting closer here. So let's bring back our logic. Rolls sub I plus rolls sub I plus 1 equal 10. Now we're in the spare category. We want to have a different score, right? So this is going to be the standard. Case, this is the spare case. We can refactor that into a function later. And in this case, we actually want to do 10 plus, so the spare's awesome. If they did, then I want to remember to do this one. If they did that, I want to add 10 to that next roll. So that's a big bonus. So one refactoring suggested is to turn this into from I to frame index. So it looks a little bit better, but I think it'd be nice if we could draw out this into, could get rid of this comment. Let's make the code more expressive. So let's say cut if is spare. No. That's what I want you to do. now we just made that a lot more intelligible. If it is a spare, then for this particular frame, we want to add 10 to whatever they've rolled in this next roll. So that's nice. Let's go back. Now let's actually see if this works. Oh, index out of range. So we actually look to see when we roll here, we're not using an array, we're using a list. So what we can actually do is say, hey, add pins hit to the end. Do we even need current roll anymore? Don't think we do. So a list makes it cleaner, a bit more heavyweight, and now it passes. So if we go look back at our test again, this was rolling a spare, and then we rolled a 3. So it remembered that this was rolled, right? We're just storing all the rolls whenever it's going through and rolling it. We're saying how many pins were hit each one. Then we go through each of those frames. If it's a spare frame, we do this math. Otherwise, we just add up, hey, you got 3 plus 3 pins in that frame, you got 6 frames. Okay. We could say roll spare. So that simplifies our life a little bit. And these are all kind of together. We roll a spare, we roll this. Alright, so we want to now test the ultimate. We want to test a strike. So why don't we just start off saying, hey, roll a strike. We know we're going to want to do that. And when you roll a strike, you're hitting 10 pins at once. And let's have something interesting. So then the next frame they hit 3, then Uncle Bob has them hit 4. Then there's 16 left, he doesn't get anything. So now we have special math even for this. It's going to be, hey, you got a strike and then a 3. So it's going to be like a times 2. Let's try it and see. We fully expect this to fail. Okay, 1, 2, 3. Well, because the strike then is the whole frame. Okay. So let's come back over. This case, we're going to want that to be an else if. Going to do something similar here. We're going to want a new strike. And in this case, it's if rolls in this index equal 10. Sorry, I should say return. Did they just hit 10 pins in this frame? If they did, it's a strike. And if they did, then we get bigger bonus. You know what, with our list, it's got this capacity, but let's go ahead and say rolls for, let's go up to, start at 0, go to 22. Let's add 0. So let's initialize it to 0. And then instead of doing add here, we will say, let's reintroduce that variable that's the current rule. Should already be that anyways. Equal pins hit. So now we're going to have it initialized instead of dealing with this business. Okay, so this was a goof here. If they roll a strike, then that takes up the whole frame. We just want to boost it one time. So let's try again. When in doubt, debug. And sure enough, it passed. So we have is strike. We could call this the strike bonus. And pass in the frame index. And if we're going to do that, we should call this the spare bonus. Looking better. This is just then the, so we could call this the, what do we call it? Normal frame. Normal for us who don't usually get spares and strikes, which is me. That's your normal frame bonus. Now we've changed code. Run all our tests. They all pass. So let's now, Uncle Bob says, let's test a perfect game. And in a perfect game, actually do roll pins. And you actually get 10, but then if you get the last frame, you get another strike. You get last frame, roll a strike, you roll another one. If you roll a strike there, you get another one. So you actually can get, let's see, 12 rolls where you hit 10. Does this work? Let's find out. It does work. So we got the idea right. Have our group of tests. And then the code itself, which isn't a thing of beauty, but it's okay. Got silly style cop telling me I gotta document my code. This list stuff is weird here. I'm not a huge fan of that. Probably best to use an int array. That's what Uncle Bob did. I tried to be fancy and I paid for it. But as you see, we broke it down. Okay, it is special cases for strike, spare, and a normal frame. And some trickiness there. One of the big realizations, though, is just roll should just store what was rolled. Score should then actually calculate the score. Alright, this is Devin Rose talking in code, working through a C# TDD kata of Uncle Bob's bowling game. Thanks a lot.